Hey there, and welcome to this explainer. I'm absolutely thrilled you're tuning in today. We are going to be unlocking the secrets of statistics. And honestly, statistics is basically the ultimate superpower for taking a chaotic, confusing mess of numbers and turning it into a really clear, compelling story. If you've ever found yourself just staring blankly at a spreadsheet or some survey results thinking, okay, what does this actually mean? Well, you're in the right place. We're going to break it all down together, step by step. All right, here's our game plan. First step, organizing your raw data. Then, we'll dive into the mean, median, and mode. After that, a quick pop quiz on raw data, followed by mastering frequency tables, another pop quiz, and finally, we'll wrap up with finding the range. Section 1, organizing your raw data, turning chaos into clarity. Because, we really have to start at the very beginning. What exactly do we do when we're just handed a giant, completely unorganized pile of numbers? So the most crucial thing to understand is that raw data is totally unsorted. Imagine you're standing at the front doors of a school, right? And you just ask every single student their age as they walk in the building. You'd end up with this totally random, jumbled list of numbers, like 14, 12, 15, 12, 13, and so on. That right there is your raw data. It's pure, it's firsthand, but man, it is nearly impossible to analyze just by staring at it. But there's a brilliant way to tame that chaos. Think about rolling a die 25 times. Your raw data is just a completely random string of numbers from 1 to 6. But if we set up a simple discrete frequency table, it completely changes the game. We just list the possible numbers on one side, and every time we roll that number, we literally just put a tally mark next to it. Once you group those tallies into bundles of 5, they become super easy to count up for your final frequency. Just like that, total chaos becomes perfectly organized. And the best part is, once your data is neatly organized into one of those frequency tables, a whole new world of presentation options opens up for you. You can easily share this data with people using pictographs, like maybe drawing a little stick figure to represent 5 students. Or you could use bar charts with properly scaled axes, or even pie charts. These visual tools are amazing because they translate dense numbers into something people intuitively understand in seconds. Section 2, mean, median, and mode, the measures of central tendency. Now that our data is nicely organized, let's explore our big 3 measures to find the mathematical center, or the typical value, of our dataset. First up, we've got the mean. When most people use the word average, this is exactly what they're talking about. And the math here is beautifully simple. You see that symbol sigma? It just means sum of. So you add up all your individual values. Then you divide that grand total by n, which is just a fancy way of saying the total number of values you have. Add them up, divide by how many there are, and boom, you have your mean. Next, we have the median. Now pay attention here because the absolute golden rule for the median is that you have to put your numbers in numerical order first, lowest to highest. If you have an odd number of data points, finding the median is a breeze. It's just the single number sitting right there in the exact middle. But if you have an even set of numbers, there isn't just one middle number. There's a middle pair. So you just take those 2 middle numbers, add them together, and divide by 2 to get their average. Finally, let's talk about the mode. Honestly, the mode is basically just the most popular number. It's simply the value that shows up more times than any other in your dataset. And here's a fun little fact. A dataset can actually be bimodal, meaning it has 2 modes if there's a tie for first place. It can be multimodal, or it can even have 0 modes at all, if every single number only appears exactly 1 time. Section 3, Pop Quiz, the Raw Data Challenge. All right, grab a piece of paper and a pencil really quick because it is time for our first interactive challenge. Let's see how this all works in practice. Okay, here's your raw data. We have 11, 4, 9, 7, 10, 5, and 6. I want you to find the median value here. Think back to that golden rule I literally just mentioned. I'll give you a second to think it over. Let's walk through the solution together, step by step. Now, if you just picked 7 because it happened to be sitting in the middle of that raw list, well, you fell for the classic trap. Remember, first, we absolutely must order the numbers from lowest to highest. So we rearrange them to get 4, 5, 6, 7, 9, 10, 11. Now, we locate the exact center. Count 3 in from the left and 3 in from the right. And there it is, smack in the middle. Our median actually is 7. So if you got that right, fantastic job. You nailed it. Section 4, mastering frequency tables, leveling up. Let's see how all this builds when we have way too much data for a simple list. If you're surveying 100 people, writing out a massive list of numbers is just completely impractical. So we need to level up. Now, calculating the mean from a frequency table might look a bit intimidating, but I promise it's really just a massive shortcut. Say 5 students all scored a 4 on a test. Instead of writing out 4 plus 4 plus 4 plus 4 plus 4, we just multiply the score, which we'll call x, by the frequency, f. We create a brand new column for this called fx. Then we sum up that fx column to get the grand total of all the scores, and simply divide it by the sum of our frequency column, which is our total number of students. Basic multiplication saves us from doing endless addition. Finding the median in a frequency table requires a tiny bit of detective work. First off, we need to figure out exactly how many total data points we have, so we sum the frequencies and call that number n. Then we use a handy locator formula, n plus 1 divided by 2. But be careful here, this gives us the position of the median, not the actual median itself. To track that position down, we add a cumulative frequency column, which basically keeps a running total of our data points row by row until we finally land on the position we're hunting for. Section 5. Pop Quiz, the Frequency Table Challenge. All right, you've got the theory down, so let's put it to the test with our second interactive quiz. This one is definitely a bit more challenging. You might want to grab your calculators for this one. We are going to look for the median age in a surprisingly large group of students. Now, what's really fascinating about this specific data set is the sheer volume of 8-year-olds compared to everybody else. We've got 12 5-year-olds, 26 year-olds, 23 7-year-olds, and a whopping 65 8-year-olds. Your mission is to use that n plus 1 divided by 2 formula to find the median position, and then figure out exactly which age group that position falls into. All right, let's break down the math together. First, we sum those frequencies to find our total n. 12 plus 20 plus 23 plus 65 equals exactly 120 total students. Next, we locate our target position. 120 plus 1 is 121. Divide that by 2, and we get 60.5. So we are hunting for the 60th and a half position. Now we make our running total, the cumulative frequency. Row 1 takes us to position 12. Row 2 gets us to position 32. Row 3 takes us to position 55. We still haven't hit 60.5, but row 4, that takes our running total all the way to 120, which means the 56th position all the way through to the 120th position is occupied entirely by those 8-year-olds. Because our target position of 60.5 falls squarely right in that middle chunk, our median age is 8. Section 6, Finding the Range, Measuring the Spread. To wrap up our masterclass today, we're going to bring the cognitive load down just a bit and look at what is arguably the simplest yet most highly effective statistic out there, measuring the spread of our data. And that is the range. See, while the mean, median, and mode are great for telling us about the center of the data, the range simply tells us the entire span of our data from edge to edge. And the math? It couldn't be easier. You literally just take your absolute highest value and subtract your absolute lowest value. That one single number tells you exactly how widely dispersed your data is. I want to leave you with this somewhat provocative thought. An average temperature of 70 degrees Fahrenheit sounds absolutely amazing, right? But what if I told you the range for that specific location swung from freezing cold blizzards all the way to boiling hot heat waves? Suddenly, just knowing the average doesn't really help you pack your suitcase, does it? Doesn't the spread, the range, tell the real story? Honestly, that is the true power of statistics. It's about looking at the entire picture to make real sense of the world around us. Thank you so much for joining me in this explainer. Keep practicing those frequency tables, and always, always keep questioning the data.